Today, we find ourselves at a remarkable point in artificial intelligence. Large language models have shown abilities that were once only in science fiction, like writing poetry and even writing working computer code. But these systems mostly work like mysterious black boxes. Companies get answers without really understanding how the AI came up with them. Researchers get answers without really understanding how the AI came up with them. Everyday users get answers without really understanding how the AI came up with them. We often wonder why the model made a certain decision, and this makes us trust it less and stops it from being used in important situations. This lack of clarity isn't just a technical problem, it stops AI from working well with human values. The challenge is to change the black box into a clear thinking machine. We need to design a model that doesn't just give an answer, but also explains the thinking behind it. Introspection, explaining why certain neurons were active and what functions and weights were important. Making the AI's internal state clear and checkable, paving the way for a new generation of trustworthy AI. The first pillar embeds introspection modules right into the hidden layers. They're not just watching, they're active parts that keep an eye on and report what the computer is doing. As data moves through the network, they track patterns of activity and how the weights are changing. Their job, turn numbers into easy-to-understand explanations. They let us know what's happening inside, right now, creating a live commentary of the thinking process. For example, neuron 847 in layer 12 was activated by the word no, flipping the meaning that came after it. Another, GELU was used to smooth the change between different ideas. These aren't vague statements. They're exact reports tied to what the computer actually did. Accuracy is key. We can check them using gradients and activations. We train this using reinforcement learning with human feedback. Experts judge how clear, accurate, and relevant the explanations are. The output is layered. You get the answer and a detailed record of how it was decided. Traditional LLMs use static embeddings, a fixed vector for each token. This doesn't capture the fluid, contextual nature of language. The word bank changes between finance and a riverbank. We're introducing dynamic four-dimensional embeddings. Each concept evolves with time and context. It's not a point, it's a trajectory. A richer, more nuanced model of meaning. 3 dimensions, semantic position in the concept map. The fourth is time, the sequential position in the prompt. We visualize and analyze semantic trajectories. The vector for bank moves closer to money, loan, finance, and shifts towards river shore if the context changes. This dynamic handles ambiguity and long-range dependencies. It's not random, it's governed by mathematical principles. Loss functions encourage smooth and logical trajectories. Push and pull rules for semantic proximity and controlled creativity. The third part is a query, the orchestration layer. It's not the main model, it's the smart interface. It manages, improves, and enriches the entire query process. Your first contact point, an extension or API with an optional sandbox. It pre-processes your prompt right on your device for speed and privacy. It uses smart semantic compression and tokenization. This reduces tokens, costs, and wait times. It minimizes or hides sensitive information before it leaves your device. It breaks down complex prompts into smaller, easier-to-handle tasks. Then, it sends them to specialized agents for each area. Each agent uses RAG to give you answers with evidence. The output is a clear answer and a full audit trail. Clear citations link each statement back to its source document. It includes explanations of key activations and decisions, an unbroken chain of evidence, verifiable step by step. Bringing together introspection, 4D embeddings, and a query gives us some really powerful benefits. The biggest one? Total transparency. We're moving past the black box idea to see exactly how the AI thinks. This is a game changer for making sure things are compliant, managing risks, and checking quality. For things like financial models or checking regulations, being able to check decisions isn't just nice, it's a must-have. It lets you trust and verify, which is key for important operations. You get full traceability, meaning you can see where every piece of information comes from. Every factual claim is linked right back to its original source document, and every internal thought process is explained by the different parts of the system: law, medicine, journalism. This changes everything. Clinical reports, legal papers, and summaries can all be easily checked. Smart ways of compressing information and focusing attention reduce the workload and cost. Lower latency means advanced AI is more accessible and affordable. And 4D embeddings make things much better when you're dealing with really long documents. This vision sounds great, but we need to look at the real challenges. Introspection adds extra computer work. Watching and explaining things makes them take longer and cost more. At first, the explanations might not be perfect or could be too technical. We need to invest in fine-tuning and expert RLHF. We need to figure out when to use the explanation mode versus the fast mode. This could depend on the user, the type of question, or how risky something seems. Being transparent brings up new privacy concerns. This means we need strong access control and ways to keep information anonymous. Next up, building a working prototype in a real-world setting. We'll add introspection to the middle layers of our system. We'll use dynamic embeddings in a smaller dimension for better visualization. We'll also have a basic A query with compression right in your browser. We'll measure how accurate the explanations are, how long they take, and how much each query costs. We'll test this in legal, medical, and code generation scenarios, with feedback from experts and users.